Hey, I know some people are having a little bit of trouble calculating confidence interval. So I thought I would take one of the examples from the slides, take a look at the guide to see which example I'm covering, and just work through it just as an example of how to do confidence interval. So to do a confidence interval, we have 5 steps. 5 steps. Sorry about my writing, but you'll have my voice to compensate. The first step is we need to figure out a point estimate. Effectively, what this is this is just what is the mean of our sample. So we've taken a sample. I'm using the example that I'm using from the slides is the average wage of manufacturing employees who have been laid off and have found other work. So the sample size of that was 750. The sample mean, X bar, was 28,373. And the standard deviation was 3,892. So first we just take X bar. What is the sample mean? Well, that was 28,373. Second step is figure out what confidence interval we want. Let's say for the sake of example, we want a 95% confidence interval. You could choose 99%, you could choose 80%. 95 is the standard, so we'll take 95%. All right. The third step is figure out, do we use a z-score or a t-score table for this? What kind of distribution do we have? So as a sample size gets larger and larger, the distribution approaches a normal distribution. At some point, it just becomes more useful to say that it's a normal distribution and call it a day. But when you're working at smaller sample sizes, it's not really, it's a little bit more exaggerated than that. So you want to take it on a case-by-case basis. The rule of thumb that we use in this course is when your sample size is greater than 100, you're safe. Just uses a standard distribution table, which uses z-score. Otherwise, use a t-score table and a t-distribution table, and take it on a case-by-case basis. In this case, we're using our sample size, n, is greater than 100, it's 750. So, using a z-score table. Okay? We're not going to cover step 5, because that's interpretation, that's in the guide. Step 4 is just calculate. All right. Then we need to figure out a 95% distribution. So, we want to figure out what are the upper and lower bounds of this, where the mean is in the center. What are the upper and lower bounds such that this space contains 95% of all our data? And then we'll do a little bit more math with that just to make sure that we get where we would expect the mean to be. But we just want to start by getting the z-score of this. So we're gonna ignore half of this for now. Okay? Just for a little while. What we want to do is we want to get the z-score of what it means to be. So we're not looking at 95% now. We're looking at 47.5%. Okay? That means that we're looking for what is this region that contains 2.5% of the data. Now here's where we get the difference between confidence interval and alpha. Confidence interval is just why we want that to be. That's the 95%. The alpha, you can think of it as alpha equals 1 minus CI. So where CI, in this case, would be 0.95. 1 minus 0.95 will leave us with alpha equals 0.05. Think of alpha as the remaining area, the area in which we're saying there is a 5% chance that we did just draw poorly and that the actual population mean is nowhere within where we're looking. All right. So we're also looking at only half of this, though. So actually, alpha is going to be equal to 0.025, which, notice that's the same thing. So now we just need to go look at a z-score table to figure out look at one of the cells. Look at cells and find the cell whose value is 0.025. Make sure that you're looking at the right z-score table. Make sure you're looking at a table that only does half of the table. All right, otherwise we're going to be looking at the entire table, and we want to see which on either side We're doing 2 tails, not 1 tail. So I've looked this up beforehand, and we find that the corresponding z-score is 1.96. Okay? Now, we do a little bit of math. What that's going to, generally it's going to take the form of z-score times sigma over root n minus 1. So if we expand that out, that's 1.96 times 3,892 all over root 749, which if we just do the math, then we see that that is 278.73. Okay, so we know that our confidence interval is going to be x bar plus or minus this number. Okay, that is the range in which we're 95% confident that our population mean appears within. So again, if we do the math, if we take our x bar, which is 28,373 plus minus 278.73, then we come up with the range 28,094.27 to 28,651.73. So that is the range of our confidence interval. That's what we're looking at. Hope this helps.